I think this is kind of an interesting plot here. We're talking about how as you intake more and more acidic things, how you just start feeling, right? Tired, headaches. But when things start getting serious, they're not so sure what's going on between getting sick and cancer. So that's kind of interesting. I lost my pen. Shoot. Where is it? Can't, there it is. Okay. And how, right, little goldfish, you got to keep that thing clean. But I think they measure pH, they measure acidity a lot more often than measuring basicity. And basicity is pOH, but they measure pH. You could measure either one, but pH is the one I think they measure the most often because acidity in nature just seems to be more common. So they measure that much more often. And like you might end up with some scales that look like this, like with a pH scale, goes from 0 to 14, and how if you have milk, it's, right? Is this getting more acidic as I go up? Yeah, it's weird. The smaller the pH number, the more acidic it is. So like black coffee is a little more acidic than milk, right? Stomach acid's way up here. Start getting into basic stuff like baking soda, blood, right? Ammonia way down there, okay? 1 molar NaOH like we used in the lab, okay? But neutral solutions, Jasmine, would have a pH of, where'd Jasmine go? Tegan, 7. How about acidic solutions? Allison, lower than 7. And then basic solutions, Alyssa, must be greater than 7. Okay. Self-ionization of water. Water actually decomposes all on its own, Crystal Munoz, and you can't stop it. In fact, liquid water breaks up into what 2 ions? What would you guess? What ion are we talking about a lot that really refers to acidity? H plus and OH minus. There it is. That's what water breaks up into. Diana, it's just a natural occurrence. It's just a natural occurrence, this decomposition of water. Or they call it self-ionization or auto-ionization. The equilibrium constant, you call it K, right? It'd be products over reactants. How would you write that expression? H plus in what? And OH negative. In what, though? In what do the brackets mean? Yeah, concentration. You can't just write H plus and OH minus. You have to put them in brackets. All that over. Good, she caught it. Over 1, because we have a liquid. Okay. All right. Now, when you have to, would this K be a big number or a small number? Monica. What would you predict this equilibrium constant to be? Pretty big, pretty small? Can't tell? Because we're talking about water, right? Isn't it mostly just water? Liquid water, right? Because you see it, get your hand wet and all this stuff. So that would mean K would have to be really small, right? Because you have to have a whole lot of reactant. So this K has to be really small. And what they're going to do is whenever they put a subscript on their Ks, like in this case, KW, you have to write the reaction in a certain way. So you have to write the reaction this way that we did, and then you'd end up with this KW.
What did you get KW, sorry?
They just slapped a W on there. They just put a little W on there because they always do that whenever you have to write the reaction a specific way, because that means that these are going to be an important equilibrium constants, and they're going to tabulate them. And if you wrote the reaction differently than I did, the K's aren't going to correspond. So everyone has to write it the same way. And that number is 1 times 10 to the negative. Does anybody know? Who's had lab? Okay. We had pH plus POH in lab was equal to what number?
14
It was equal to 14. That's where this is coming from. Okay. KW is really just 1 times 10 to the negative 14. So is it a big number? Definitely not. All right. It's extremely small. All right. A millionth of a billion almost. Okay. Helpful hints to predict pH of strong acid and base solutions. So we're going to be doing this. We're going to be calculating pH and some other things to describe the acidity or basicity. These three things will help us get there. We're not at the calculations yet, but know the names and formulas of the 6 strong acids. You have to be able to recognize them. Because the key there is that they dissociate 100%, right? I guess that's right down here. Know the names and formulas of the strong bases. The strong bases were what? There's a solubility rule that I harped on last semester. You put these metals with anything, they always dissolve 100%. So you put these metals with OH, alkali metals. Good. Sodium, lithium, potassium. Those are your strong bases. Okay, those are your strong bases. Now, why is this such a big deal? Because they dissociate 100%. Well, what does that mean? If I had 0.0012 molar HCl, what's so special about HCl? It's a strong acid. So that means, what would be the concentration of H+? If I know that if I have 0.0012 molar HCl, it dissociates 100%. So every 1 HCl, I get 1 H+. Won't its concentration be the same? Yeah. That's what makes it easy. So that's why you have to know all these darn strong acids and bases. If I have 0.28 molar KOH, well, then you know what? Erica, what would you know now? What's so special about knowing this pertaining to what we're talking about? Then you know the... No, you don't know pH. You know the OH concentration is what? 0.28 molar. Okay. Does that make sense? Do we need to do more of those? All right. I have 0.23 molar HNO3. Well, then I know what? Then I know what? The the hydrogen ion concentration, because that's going to help you. We need to know because when you say this is what's in our equations. So get used to seeing that it is a mathematical symbol. When you see that symbol, you know what the words are, because that'll match. It'll make it a lot easier to find the right equations. So you know this is 0.23 molar then. Okay, so that's the idea. Now we have a bunch of equations that we're going to be working with. And if we take a look at these, let's pretend we're interested in the hydrogen ion concentration. There's 2 ways to get it. We can get it from, because notice it shows up here, and it shows up down here. Right? There's 2 ways we can get hydrogen ion concentration. But I don't give you the top. This is all I give you in the homework. Sorry, in the exams and quizzes. You have to mess with rearranging these. So let's try this here. crystal Zamora. Let's rearrange this equation 1. Right? pH is a negative log of H. How are you going to rearrange that to get the hydrogen ion concentration?
So you have to take off the negative log.
Good. Got to get rid of that negative log. Let's bring the negative sign over first, and then we'll raise both sides to the what?
E? Is it that function?
What was the exact inverse of the LOG? Not E, that's LN.
Oh, it's just, yeah. I know it's just the side. Like, because you raise it to the 10.
10. It's 10. Right? So it might look something like this. If 10 to the negative pH would equal 10 to the log hydrogen ion concentration. And these are inverses, so they cancel out. So what you end up with is 10 to the negative pH is the hydrogen ion concentration. Okay? So you need to be able to rearrange these guys to do this. Okay? 10 to the negative pH is the hydrogen ion concentration. We'll practice that. We'll do some problems on that. But we could also use equation 4. We have the hydrogen ion concentration times hydroxide is 1 times 10 to the negative 14. So Gabby, if we were going to use this equation 4 to get the hydrogen ion concentration, they would have to tell us what? They would have to tell us the concentration of OH, right? So that's when you use this. They told you the hydroxide concentration. What's hydrogen ion concentration? Okay. Well, how would you solve this, Sabina, for the hydrogen ion concentration? What would you do? Yeah, they gave you that way. Well, let's just we want to solve for this guy. Divide both sides by the OH. Yeah. Divide both sides by the OH, and you'll have it. So hydrogen ion concentration is 1 times 10 to the negative 14. 1 times 10 to the negative 14 all over OH. Okay, so we just have to know how to manipulate these. Likewise, there's 2 ways to find the hydroxide, right? We have a similar relation. Now we've got POH is negative log of hydroxide. Well then, how could you find hydroxide then? What would be hydroxide? 10 to the negative POH. Right? Over here, what would be hydroxide? Just divide both sides by hydrogen ion concentration. Okay. So it's not so bad, right? So here's a couple to practice on. They said that the hydrogen ion concentration is 3.8 times 10 to the negative 3. What's pH? So Derixa, what equation should we probably be using for this? Which number?
4?
Number 4?
No, no. Well, I want to say the 1, but then the 1 times 10 to the negative 14.
Why not? You want to say 1? Why not say 1? Look at that. Because all you do is you plug in the hydrogen ion concentration and we'll have it.
Okay.
Yeah. I'd use equation 1.
How do you input it in a calculator, the log?
Good. Let's do that. That's the goal. That's the real reason why we're doing this. Okay. So we have to say pH is a negative log 3.8 times 10 to the negative 3. Very good, Crystal. That's really why we're messing with it. So what I would do is I'd plug in the 3.8, and then EXP, remember, is the 10. EXP, 3 negative, 3 plus minus. So I have 3.8 with a little negative 0.3 up in the corner. Now all I do is just push the log button. And I get negative 2.42, but I dropped the negative sign. So 2.42. So make sure you can get that. Make sure you can get 2.42. In C, they give us pH. What's the hydrogen ion concentration? Probably use what relation? Yeah, first one again, right? Except you need to rearrange it. Probably end up writing what expression? Yeah, right here. Ten to the negative pH. Now let's try putting this one in the calculator. 10 to the negative 2.85. So how do you do this? You can raise anything you want to any power using the x to the y button. So we want to raise 10 to some power. So I'd push 10 first, and then push the x to the y button. It's right above the c. And it has to be a negative 2.85. So 2.85, push the little plus minus. What did you get? About 1.4 times 10 to the negative 3? Right? Now, notice pH doesn't have units. Concentrations do. We should put what units on this? Molar, big M. Otherwise, you're going to lose a point. Okay. One more, then we'll go to the boards. If the pH is 8.35, what is hydroxide? pH is 8.35. What is hydroxide? From 4. Okay, there's. Gabby's got one idea. She's using this one.
Oh, 3.
She's subtracting, right? They want to know what hydroxide is. They gave us pH. So we know this one. She said subtract it, right? Subtract this from 14, bring it over there. Then you'd have POH. Then you could use the expression 10 to the negative POH is hydroxide. That's what she's planning on doing. I think that's a clean way to do it. There's another way to do it. You could use this to find hydrogen ion concentration and then plug it in down here to get hydroxide. But it's a lot more typing. I like the way she's doing it. It seems faster. Whenever you can use this pH plus POH equals 14, it'll be easier on the calculator.
And after you subtract it, what do you do with pH?
Well, then you have this expression. Then you have to use that one.
Which expression?
POH expression to get hydroxide. You get somewhere around 2.24 times 10 to the negative 6. Good. Okay, make sure you can get it. If you can, you're doing everything on your calculator, right? Okay. No problemas? All right. Go to the boards. It's Rixa's favorite. Okay.
It's my nap time.
That's why we go to the boards. So what is the hydrogen ion concentration in 0.25 molar HCl? Turn this on for you. What is the hydrogen ion concentration?
So I use 1. I can use 1.
See what people are...
Oh, it's because it's a strong
It's a strong
acid.
acid. So what's the hydrogen ion concentration? 0.25. And make sure you put units on it. Right?
So like,
Wait, it's the same
I'm going to
for-
use 1.
So what is the hydrogen ion? This is a strong acid. So that means it's going to break up 100%. So the chloride will be 0.25 molar. Well, so will the H plus. 0.25 molar.
I want to waste some chalk.
That's why we got to know these strong acids. All right.
It works for beef and not C.
Yeah, C, you're going to have some work in. So for B, you see the answer, right? Hydroxide is 0.15. But now for C, you do know something. You should write down what you know. You know what for C? Hydroxide is 0.15. That's where you should start for C, because it really guides you as to what equation to use. Right? So for C, I would write down what you know. That's where you start. So you could go the POH route, or do it in one step with equation 4. So there's 2 routes you could go. Make sure you can get all this stuff in your calculator. I think that's the confusing part. No. You did something wrong in your calculator. 1 times 10 to the negative 14.
Because I just do
1. No, how do we do exponents? EXP. 1, 1, EXP, 14, negative. That's 1 times 10 to the 14 negative. Now divide by 0.15. Yeah, see, you're off by 10. Make sure you get 10 to the negative 14, otherwise you're doing the same mistake over and over and over. Right? So C should be 6.67 times 10 to the negative 14. I think most everyone's got it. If you got it, go on to the next one.
What about negative 4?
No, negative 14. Because this one's downstairs.
Oh, whoops, I put 4. Nope.
All right.
You laughed.
Oh, there's another one. There's part D. What is the pH of 0.05 molar NaOH?
Wait, sir.
Okay. Good. I see a lot of 12.7s. For part D, yeah, you should get 12.7 when you finally get it. Well, you could, but I think it's easier to use this one.
Okay, and this number would go in the POH.
Yeah, take the log of it, though. Right? Because you have to find POH, and POH is the negative log of this.
Oh, yeah.
So take the log of this, and that will give you this.
Be that way.
Yeah, well,
Well, the 1.3.
yeah, but then you got to subtract from 14, so it's already negative. You just add it to 14.
Oh, wait, so then.
Mm-hmm.
So it's 10.
Yep. Okay, so if you got 12.7, let's check out the next one. Make sure you can get it, though. If you didn't get 12.7, let me help you out. Did you get 12.7? Okay.
Okay, I use this one first. And then this number here.
It goes right there.
Okay, so I just put it here, right? And I do negative log, right?
Yep.
But when I put it here, use 0.05
Log.
log.
There it is.
And I take out the negative, or I leave it.
Well, you can take it out because you have to.
1.30
This is POH.
is POH, right? Okay, and then I use my pH.
Yep.
Okay.
Now on 53, hopefully you realize you could just cross out H3O plus and write what? H plus. It's more recognizable. But hydronium is the same as the hydrogen ion. So, oh, you didn't find POH. So what you need to do, oh, you did it right here. You even did it. So this is hydroxide's 0.05. This has to be POH, not hydroxide. And POH is negative log of OH. So you have to take the log of this, negative log of this, and that number goes here.
Oh. So in this one I can use 4.
That's 4.
You can
Mm-hmm. There's two ways. There's almost always two ways to solve these. if you use this, it'd be one step. It'd be a lot easier, I think. But you don't have. You can go the pH plus POOH route if you want. But
Wait. This step? One step?
yeah, 'cause you know what H plus is. It's a sulfur OH.
What is H
Right. So the very first thing you should be writing is the knowns. 1.2 molar equals the concentration of H plus. That's the very first thing you should be writing on these, because it helps you find the right equation.
So 8.33 times 10 to negative 15 is my OH. Don't forget your
Making sense? Okay, keep going. And don't forget your M. So keep going if you got these.
Oh, I
Go on to the next one.
got this
Yep.
Is that right out 14 and then it gives us a pH, or like you did a pH by dropping it?
So you're doing 77, right? Yeah, so you found POH is 2.37. So what equation can you use then? 10 to the negative POH is hydroxide. Is hydroxide. Yep.
Which one's that one?
Oh, just because you got it.
Yeah, I did. 5.27.
I don't know. I just made it up. I could be wrong.
Yeah, you made that up. Totally.
Not even close.
I know. Good job, Dr.
I thought I stole that from Jasmine. Maybe I did it wrong. POH is 2.37. About 4.26 times 10 to the negative 3. Big M. Okay. So here we just, only 3 left. You guys can get out of here early if you. And 63, you just write acidic, neutral, or basic. Nothing to calculate.
4.2 times 10 to the negative 3? What is that? The other one?
Probably. Don't forget your units. Big M. Acidic, neutral. Yep. I don't know about these though. But here, just take negative log of that. That's all you gotta do. They want the pH. And that's the hydroxide concentration.
Hydronium's H plus.
Hydronium is the same as H plus.
How do I do that? Do you know what to do?
So the last one, they give you a hydroxide. Just got to find pH.
Got it. You give me what? The OH.
They gave you OH in this last one.
OH minus.
See you later.
How did you put the 15.67 in the calculator?
67. I did 7.5 EXP. That's the times 10 part. 3 negative, and then just log. You have one of these calculators? You're going to have to use this on all the quizzes and exams.
I forgot it today. I have it. I swear I did.
Here's, so have a good day.